This young man seems to see the future. Throughout his life, this will be the essence of Jim Watson's genius. At 23, when his bosses tell him not to work on DNA, he ignores them. He discovers the double helix and wins the Nobel Prize. When he writes a book about his life, his friends say it's too candid, but he ignores them and publishes it anyway. It's a bestseller, and he becomes a millionaire. When he begins his biggest venture, the scientific establishment tell him it's not practical, but he persuades the U.S. Congress to give him $3 billion, and now the human genome has been mapped. When it comes to the future of DNA science, nobody has a better track record than Jim Watson. But today, he has a vision of the future that many find disturbing, and some people wonder if this time his judgment has finally gone off the rails.
I find myself, realizing that most people don't want to hear important truths. And so, for the most part, I don't try to annoy people. But some occasions, you just feel someone has to get up and say what you think. And that offends people.
DNA is the molecule that controls life. It's in every cell of every living thing. 50 years ago, almost no one knew of its existence. But today, the human race is unlocking its mysteries. And when you understand something, you can start to control it. DNA scientists are moving ever closer to the day when genetically engineering people becomes possible. Choosing the characteristics of future generations, screening out the genetically undesirable, designing our own DNA. The possibilities of this technology seem limitless, but perhaps there are moral limits on what should and shouldn't be done. Who should make the decisions? Where do you draw the line? We asked Jim Watson for a guided tour of the future, a look into Pandora's box with the person who opened it. We begin here, at the world's leading producer of genetically modified foods. Their desire to enhance nature makes Monsanto one of the most controversial companies in the world.
The purpose of a growth chamber is to provide an idealized environment for the plant.
For this reason, many scientists would be apprehensive about coming here. But not Jim Watson. He loves GM food.
One of the adult Colorado potato beetles is on display on that white
Where are the potato beetles?
What Monsanto does is add genes to their plants, changing their genetic makeup to suit the farmer's needs.
We have here 2 cotton plants. This is what a cotton plant would look like in the old days. Sick and diseased, and there's nothing you want to see here. And here's one which has been genetically engineered to produce this protein which absorbs the insect guts and kills it quite fast, within a day or so. This is a perfect plant. And if you wanted, an insect-dominated world, this is it. But this is rational man's dominated world. And to me, this is the future.
What Watson knows is that what has been done in cotton and corn could one day be done in animals and people. But even Monsanto draws a line here.
Okay, so they're not trying to do transgenic animals?
No, we
in fact, they've made a series of public pledges about things they will not do.
Just plants.
And we won't put animal genes in plants. It obviates the problem of, is it still vegetarian or not?
Oh, Jesus.
Fortunately, bacteria have plenty of
I sense the tide has changed, and genetic manipulation will be more and more accepted. A lot of people don't want the world to be changed, but we shouldn't be too upset. We just have to go on with our business. We want to make the world better. You know, there are people who say, well, we're playing God. And, you know, I have a straightforward answer. If we don't play God, who will?
Watson has turned this picturesque harbor on the coast of Long Island into one of the world's leading genetic labs, Cold Spring Harbor Laboratories, of which he is president. Watson lives on the grounds and has a 20-foot statue of the DNA double helix in his front yard. He's built a bell tower capped by the 4 letters of DNA's genetic code.
I know Dr. Watson would accommodate him whenever it would be convenient.
This is Watson's office. Here one sees more evidence of his achievements. That's the Medal of Freedom of the United States. Amongst these mementos and awards, he explains what's at the heart of his philosophy.
One often hears the argument, what right do you have to interfere with nature? And, but the nature out there isn't the product of a great design. No one's written a book. It's just evolution happening. And this evolution depends on random changes in genetic messages, which make some organisms better able to survive and others not that able.
Watson's science has shown that all living things are controlled by their DNA code. It's this 4-letter code that makes not just plants and animals, but people too. And Watson believes that random changes in this code largely determine who we are and what we are able to do.
Some are too short, some are too tall, some are too fast, some are too thin. So nature can be pretty cruel. Weather can be cruel. Our heredity can be cruel.
And that's why the old wooden buildings of Cold Spring Harbor have been turned into laboratories where scientists work on DNA. Ultimately, the aim is to improve the genes of future generations. But if that idea rings alarm bells, it might be because the concept has a dark history. Long before it was possible to manipulate DNA in the laboratory, there were people trying to change the characteristics of their descendants. Ironically, the American center for this was Cold Spring Harbor, as Watson reveals in his own archive. The first president of Cold Spring Harbor was this man, Charles Davenport. And his passion was a subject that is frowned upon today.
Here's a little pamphlet by Charles Davenport, published in 1910, called Eugenics, and it was published for the YMCA Health League. And the first chapter is called Fit and Unfit Matings. And this is what Davenport called the science of human improvement by better breeding. Eugenics World had booths at agricultural fairs in which you didn't display prize sheep, but you displayed prize families. And now it seems pretty ridiculous when you look at the pictures. You can't really understand why anyone would call these prize people. The idea was if someone had a mental disease in the family, you didn't want to marry into it. So people hid mental disease. You wouldn't want to admit that your aunt was a bit wacky. The thing was the burden of the feeble-minded. Who was going to take care of them? And people began to try and look how feeble-mindedness moved through families. And at Cold Spring Harbor, they set up the eugenics record station just to do masses of pedigrees. They were going to prevent the unfit from taking over the world. Here's an apparent 5-generation family where feeble-mindedness just runs through the thing. And you can see here, F, 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 F. And I wonder how many of these kids went to school, or under what conditions, and how they were tested, and who said this. But this was the sort of thing which affected social policy. The legislatures, who really didn't understand the science or the strength of it, passed laws to sterilize the unfit.
Incredibly, as a result of Davenport's eugenics, 40,000 women were forcibly sterilized in the United States. Watson thinks he has an insight into how that could have happened.
Most people now don't remember when there were the massive mental hospitals throughout the country. Throughout, in fact, the civilized world, there was no treatment for mental illness. The people went into them, they never left. And this was, eugenics was, I think, the response to these large hospitals.
This makes Watson more forgiving of the early eugenics movement than most.
It sounded like a good idea, and it wasn't. I don't regard Davenport as an evil man. By the end of his life, you can say he did dreadful science, and they were sort of telling the people there was science behind it, and there wasn't science. There was just some unfit people, and how do you handle it?
In Watson's mind, this chapter of eugenics shows the harm that can be done when governments try to control the gene pool. As it turned out, enough people in America were against the policy, and Davenport's work was stopped.
By the time the 1930s arrived, many people effectively thought Davenport had lost his bonkers. Eugenics was just silly prejudice. Unfortunately, as it lost favor in the United States, Hitler came to power in Germany and liked very much the ideas of the unfit, and he wanted to get them out of German life.
Watson has his own kind of eugenics, based on his DNA science. But he feels that people are prejudiced against it because of one other way eugenics was put into practice in the past.
The Germans and the Nazi government was their aim to produce the pure Aryan race. Broke the cardinal rule of civilization. Thou shalt not kill. So people they thought genetically inferior, they killed. The name of genetics they killed. And so in the public eye we will always be identified with the Holocaust. Now here's the Reichstag.
Jim Watson is drawn to Germany. He's come here many times. Of all the countries on Earth, Germany is the most hostile to genetic science, probably as a reaction to its Nazi past. It's almost as though Jim is in a personal battle with Germany. Many Germans feel that one of the lessons of the Nazis is not to try to use genetics to improve the human race. But Watson feels they need to come to terms with their past and then move on to embrace the new genetics. He says the idea that people are the result of their genetic code is a truth that cannot be ignored.
When I walk down the street and think about my fellow human beings, I see all of them as products of that script. But the products of several billion years of evolution, where the script has become more and more refined, so it finally says human being. The imperfection is not any grand design. It's just a mistake.
The scientific evidence on this is compelling. Already it's been shown that a single letter mistake in the genetic code causes diseases such as cystic fibrosis and thalassemia. And it looks like multiple mistakes cause complicated mental illnesses like schizophrenia and manic depression. Throughout history, such people have been discriminated against for something that Watson sees as just the result of a bad roll of the genetic dice.
There's no design. These humans have no chance of really competing with most other humans. So what do you do with the unfit?
This is a mental hospital 60 miles outside Berlin. The place where the eugenics from Cold Spring Harbor was taken a stage further.
Clearly to inspect, that you could inspect what's going on.
Watson is being shown around by his friend Benno Müller-Hill, who has studied the history of German genetics.
And that's right here. And you see it looks first, if you are innocent, you believe that this is in fact hot water which may come out of this, but no, carbon monoxide is coming out of here.
14,000 mentally ill people and disabled children were killed here in the name of eugenics.
The dead bodies were then taken out of here, and one could get them out of here into a room where there is at the moment just one dissection table, dragging them here on this floor.
Do you think they felt they were murdering people?
They couldn't see anything wrong with killing those incurable insane, and they had learned this in the medical courses at the universities, and so they couldn't see anything wrong. And probably
This basement has been preserved as a museum to remind people of the Nazi genetics.
I was active as somebody who was burning the corpses. The oven would be always new, filled.
Above them, the mental hospital carries on as normal. And for Watson, the problem of the unfit remains. And so does the argument of what should be done about it.
Last year I was attacked by the president of Germany for sort of Hitler-like thoughts.
Yeah, the chief of the German Medical Association has asked the Nobel Prize winners of throwing you out of this community, of their community, because you are so Hitler-like. Yeah.
Well, because I believe that, that a woman should have the right to terminate a pregnancy if the child is going to be genetically unhealthy. And, that's what I said, in very unambiguous terms, that a woman should have the right. I didn't say a woman should be forced to or not forced to. I just said a woman should have the right to try and have a healthy child. And if she has a genetic test says that that child is not going to be healthy. And I think they got particularly upset over Down syndrome, which is so accepted by at least the vast majority of people in the United States.
You said that the child should be successful, and I think that they just flipped out over that.
Well, I think everyone has aspirations for their children. It's not nice when you have a child for which you can't have aspirations. That's what I said.
Yeah.
The women cry when they can't have aspirations for their children. It's awful. We have to not defy common sense. Just because someone can say, well, Hitler also had this idea. So I think we're paying, Hitler's got us twice. We're hostage to what Hitler did. And that things which we might say are sensible, we can't do because people say, well, Hitler would have done exactly the same thing. And that worries me.
Watson has been attacked because he supports a new eugenics. By the 1970s, scientists were beginning to identify mistakes in the genetic code. Since then, pregnant women have been offered tests to see if their unborn child has a genetic defect like cystic fibrosis or Down syndrome. If they do, they can choose to have an abortion. And that's where we are today. And this is where Watson's eugenics begins. He says it differs from the eugenics of the past.
Eugenics is sort of self-directing your evolution. And the message I have is that individuals should direct the evolution of their descendants. Don't let a state do it. I think it'd be irresponsible not to direct your evolution if you could, in the sense that you could have a healthy child versus an unhealthy child. I think it's irresponsible not to try and direct the evolution to produce a human being who will be an asset to the world.
D, 1, 2, F, G.
But in Watson's eyes, who's an asset to the world and who isn't? Mr. and Mrs. Harrington have 3 sons. Their youngest is named Matthew, and he has Down syndrome.
What's that one?
Dismissal, go home.
Dismissal and go home.
All right. Yes, you want any further?
Sit back.
Come on, sit it up. Let's go.
What, you echo?
You want an echo? No.
All of my pregnancies, we never had any genetic testing done with any of the boys. I didn't even occur to me there was a reason to do it. We just figured we were ready to have a family and we would have a family.
Sure.
First son was born at the birth center. Peter was born at a hospital because I was overdue.
Sure.
Matthew was born at the birth center, and we didn't know anything until he was born. We found out right away that he had a heart condition. And I noticed some different things about Matthew. I kept commenting on his eyes, and I kept kind of feeling the back of his neck.
Yes.
So I think somewhere down inside I knew there was something, although we hadn't been told yet.
Yes.
And it wasn't until the next day when we went to the pediatrician that she told us that he had Down syndrome.
If you were pregnant again, would you test yourself?
No, I don't think I would. I think that there would only be 2 reasons to do it, and one is to prepare yourselves and inform yourselves of whatever might be helpful if you have a child with a disability, and the other reason would be to decide not to follow through with the pregnancy. And for us, we were having a baby, and that was all it was about.
But the Harringtons are concerned that people like Matthew are becoming rarer and rarer. Hundreds of thousands of women worldwide take the test for Down syndrome. The vast majority who test positive have abortions. For Watson, this is the only way we have to eliminate the disease. For the Harringtons, it's the elimination from society of people like Matthew. So they ask that people think twice before making these decisions.
On Sunday, he and I go to the beach. And we've been doing this for 4 or 5 years. He and I go out into the water. And if it's a calm day, I hold his hand. If it's a slightly wavier day, I hold him. And you know, he holds real tight and we jump over the waves. And then he goes in and sits on the shore and I ride a few waves and he likes to grade me. But 3 weeks ago, on our last trip out this fall, we went into the water. And it was a pretty calm day. We were about up to our chest, and my chest, I was holding him. And all of a sudden, he asked to be let go, and I let him go. I mean, he's become quite comfortable in the water. And he rode this modest wave in, probably went 7 feet. And, you know, he turned over and then popped up, startled at first, and then he realized that he had ridden the wave in by himself. And the look on his face and the look on my face, and he just opened his arms, and it was one of those moments of just such pure joy that he and I had anticipated this for 4 years now. He realized he had achieved this, and I realized I had achieved it, and I didn't think, is he doing this before other kids do it his age? It was just, it was just the accomplishment that we shared together that I think is just, it's something that I have with him that, you know, I wish more people that were considering life choices could feel that, could see that, could realize that, yes, the hurdles, there's a longer approach, and you approach it together. He clears them by himself, but there's just a magic in watching him do it. That as your other kids zoom through their hurdles, you might not appreciate in all the same ways.
We have a son with severe disabilities. He's very, very intelligent, but he can't take care of himself. And so he was, didn't speak till he was 4, very late, which, you know, we thought didn't mean anything, but it did mean something, and doesn't like to shake hands or be hugged.
We have a bit of the opposite in our house. You know?
Yeah, no, and it's a...
that must have been very difficult.
Yeah, it is. And, but if he can get by that first initial barrier, then he can be talk and quite charming, and but his sort of natural impulses to pull away from people. But, you know, at times I think, you know, we're almost broken. You know,
This is something Watson rarely talks about publicly. His son has a form of mental illness which is likely to have a genetic basis. When it comes to faults in DNA, almost everyone on Earth is touched in some way. While Down's syndrome affects 1 in 1,000 families, mental illness affects 1 in 4. This is Pilgrim State Hospital. In the 1930s, it was the largest mental hospital in the world.
there was this term snake pit. You came here and you never left. I think that was the awful thing.
Not far from Cold Spring Harbor, it's the kind of place that motivated Charles Davenport's eugenics.
I find this very creepy. I just would like these buildings to be torn down. You can think of all the sorrow and agony.
But although today there are treatments for mental illness, there aren't any cures, and Pilgrim State Hospital still houses hundreds of patients.
Now this is the hospital building. They come when they're just admitted. Because, you know, just the horror when, you know, parents come here and just have to bring their children here, or their we still don't know what's wrong with the people at the, you know, you can say, when you know cystic fibrosis, you know that you know, there's a gene missing. But in mental disease, we haven't found one gene yet where we can really say what's wrong.
And it was this desire to find the genes that caused mental illness that took Jim Watson all the way to the United States Congress to ask for the $3 billion necessary to map the human genome. And now it's done. This work enables scientists to read through the entire genetic code that makes a person. Now they can search for any human gene. they're moving beyond simple genetic mistakes that cause Down's syndrome and cystic fibrosis to more complex traits. They will pinpoint the genes responsible for everything in our nature, whether we're likely to be gay or straight, fat or thin, suffer from depression, or have a high IQ. And recently, the first gene involved in mental illness has been found. But this opens up another set of moral dilemmas. Should prospective parents be given this kind of information about their unborn child? And where do you draw the line? Consider manic depression. Watson suggested we visit Kay Jameson. We asked her to draw her family tree. The crosshatches represent manic depression. The stars, suicide attempts.
My brother, who's very normal. Myself, who is not. Suicide attempt. My sister. My father, my father's mother. Her brother, who was in an asylum most of his adult life. Let's see, many of my cousins affected by this, and my cousins' children continue to have problems. I have the same illness. My sister has the same illness. So if you just look at that side of the family tree, it's just saturated.
Eugenicists like Charles Davenport were right. Mental illness often does run in families. Listening to Kay, one might wonder how far society has come since the days of people like Davenport.
I went in to see a doctor, and the doctor took a family history and knew I had manic depression and told me that I should never have children because I had manic depressive illness. And it was one of the more upsetting things I had been through in terms of just an experience with another person. I couldn't believe, first of all, I couldn't believe the cruelty, because it was said with such a level of certainty. There was not any question of being wrong. I mean, he absolutely knew that what he was saying was correct from his point of view, that I had a very bad psychiatric illness, and I should not let loose into the world any more people that had those genes. I wasn't asking his permission to have children. It didn't strike me that it was any of his business. And I told him to go to hell. I also told him that I was the director of the mood disorders clinic at UCLA, and I was completely aware that it was a genetic illness.
Kay Jameson isn't just a patient with manic depression. She's also arguably the world expert on the subject. She's a psychologist and has written the definitive textbook on manic depression, as well as a best-selling autobiography about her experience of the illness. She knows.
When people assault your genes, it's just like saying you ought not to have been born.
One of her recent books examines the link between manic depression and creativity.
When you're talking about genius, I think you're talking about people who are, by definition, it's a very unusual set of circumstances that leads to that kind of mind and ability.
So does Watson's way take into account the positive sides of something like manic depression?
I think it's something it's a hard argument. If you wanted to say, well, what percentage of human creativity is associated with manic depressive illness? I have no idea. You know, I think there'd be a lot of creativity without it.
If you look at the scientific literature, there are more than 20 studies showing a very much elevated rate of depression and manic depression in people who are highly creative.
What Kay knows is that all these people were manic depressives, so there's a risk that Watson's science could deprive the world of these extraordinary people. Watson argues that this doesn't make up for the misery that goes with it.
This is sort of saying, what's more important, what's good for the country or what is good for the individual? And my way was always asking what's good for the individual. I mean, Someone would say, well, our society would be greatly impoverished if there were no homosexuals. But would you make someone be born homosexual because they're good for society, knowing the difficulties it's likely to impose in their lives? I certainly wouldn't use that argument. I would go back to it. I don't see how you could decide the answer, and best to let parents decide. I think most families that have manic depressive disease would decide to have children without it. So that's about all. It's a terrible curse.
I think that parents will be diverse in what they choose. I think if I thought every parent would come down with a decision not to have any manic depressive illness floating around in the genes, I would find that disturbing, because I do think the diversity is important.
For Watson, whether manic depressives become an endangered species will depend on the parents of the future. And he asks, would you want a child who could be highly creative but might be suicidal? Or would you just want to ensure your child was healthy?
Yeah.
There is another more radical way that DNA science could deal with Watson's unfit. Instead of aborting them, people could be genetically engineered. Since the Human Genome Project, DNA science has gathered pace. And now, if you have the money, you can get a printout of your own genetic code. These are some of the G's, A's, T's, and C's that make a Jim Watson. Now imagine you could change these letters around. Maybe people could even make themselves more intelligent or better looking. But should science be used in this way? This is what the scientists call the question of enhancement.
Oh, I think people who say we should try and enhance people in the future haven't thought it through. We're always trying to enhance things, and suddenly they say, oh, you can't enhance your genes. Well, that's sort of says something, mystical about it. As if you don't, it's the Holy Grail, or it's some, out of King Arthur's court, you're not going to mess with it.
That might sound like science fiction, but not if you meet one of Jim's former students, the next generation of DNA scientist, Mario Capecci.
Jim was a very important influence on my life. Literally, we live in the future, and we imagine things, and we dream about things.
He has his own billion-dollar enterprise, the genetic enhancement of mice. And the reason he does that is to develop the technology for use in people. The process begins with this machine. The bottles at the bottom are full of the ingredients of the genetic code, because this machine can make DNA.
This is an automatic DNA synthesizer, and what you can see here are the nucleotides A, G, C, and T. And so what this machine can do, we can program it to put in, as we're synthesizing the DNA, we can specifically put in A at this position, then a C at the next position, and a T, and so on, and then thereby resynthesize a part of a gene. And so in essence, we have the capability of changing the genome in any way we see fit.
He then has another machine that incorporates the new piece of DNA into the mouse cell.
We put an enormous voltage jump on this, and in the process what happens is that the little holes are opened up in the cells, and the DNA slips into the cells and then goes into the nucleus and then participates in making the DNA of the mouse.
In this way, he can change the mouse embryo when it's just a small cluster of cells, and then observes how the new DNA affects the way the animal forms.
Will it affect the growth of cells? Will it affect making particular bones? Or will it affect making the muscle or the tendons in that limb? Or will it affect all of those?
This is one of the best ways to study what specific genes actually do. He sees how the new DNA affects the embryo, how it changes the adult mouse, even how it alters the mouse's offspring as the change is passed through generations. This mouse has had a gene switched off so it cannot move its face muscles. It cannot blink. Now that might sound cruel, but Mario Capecci does this because there are children who are born without the ability to move their face muscles, and his research is designed to look for a cure.
The amount of knowledge that we get by studying the function of a gene in a living organism is enormous. I mean, most of our previous knowledge, we were off completely as to what a gene is doing in a living organism. And the only way to find out is actually to alter it and see what happens. Genetically, mice and humans are almost identically. That is, the 99.9% of all the genes in a mouse and a human are going to be the same. So whatever actually we learn in a mouse is going to be directly applicable to humans.
The technology that he's using to do this could have another application. Just as Dolly the sheep has opened the door to human cloning, Mario's mouse shows the way towards human enhancement. But if the technology were to be used in this way, would science have crossed the threshold of what's acceptable? Most agree that Mario's work should be used to cure illness, but many question trying to use it to make us more intelligent. However, Watson doesn't see a clear distinction between the two.
By saying healthy, your brain is also healthy. And if you really are stupid, I would call that a disease. Stupidity is, a disease of the brain. The lower 10% who really have difficulty, even in elementary school. What's the cause of it? A lot of people would like to say, well, it was, poverty and things like that, but it probably isn't. And so I'd like to get rid of, help that lower 10%.
Does Watson draw the line anywhere? How about more cosmetic changes, making people better looking?
Everyone's saying it would be terrible if we made all girls pretty. Okay? Well, I think it'd be great.
And it's those kind of comments that make some people think that Watson's judgment has gone off the rails. They argue it would be crazy to make such changes to our DNA, lumbering generations to come with our current cosmetic preferences. But before discounting his views, one should hear what else Capecci is planning. He's turned his attention to chromosomes. Our DNA is wrapped up into 23 different sets, which carry our genetic traits from one generation to the next. Capecci doesn't want to tamper with any of these. He's thinking about making an extra artificial chromosome. It would carry a bundle of genetic improvements, which he could switch on and off, just like he does in mice. The artificial chromosome could even be upgraded like computer software before being passed on to the next generation. Any alteration comes with a kind of money-back guarantee.
It does in the sense that you're not stuck with it. I mean, you're not changing the genome forever. You can change it, and if you're pleased with the results, you can keep it. If you don't like it, then you get rid of it and go back to the previous situation. And this is very important because what we may think is brilliant today, 20 years from now may seem pretty stupid. And whatever they think about in 20 years from now will be stupid 20 years hence. So it's very important to make the system reversible. And I think that's technically possible.
What's wrong with it? You would say, well, give them an unfair advantage. But some people now are born with, much better abilities than others. And we don't say they shouldn't be born.
It's graduation day at Oxford University, a university famous throughout the world for academic excellence. But it's a place where only the most intelligent are allowed in. For Watson, these kids were just lucky in the genetic lottery. But why can't those with bad genetic luck be allowed to improve themselves or their children?
It seems unfair that some people don't have the same opportunity.
Watson thinks it's inevitable that this inequality will be overturned.
Once you have a way which will improve our children, no one could stop it. If you had the technology, you'd be stupid not to use it, because someone else will. Those parents who enhance their children, then their children are going to be the ones that dominate the world.
It's good to see you, man. I can see anything.
A lot of people dislike genetics because we're talking about inequality, and people say who have cystic fibrosis, they don't want to be declared unequal. And so they can say, we're different, but basically it doesn't matter. Deep down when you get close, it does matter.
Cystic fibrosis is just one of 5,000 genetic disorders that have so far been identified. One in 25 people carry the gene and therefore have a chance that their children could suffer from it. The cause of genetic disease is one of the many things that 50 years ago Watson helped explain when he made his big discovery. When he saw the beautiful spiraling double helix shape of DNA, he saw how DNA copied itself, how genetic instructions could be passed on through generations. But he also saw that his copying process could make mistakes. These mistakes could occasionally be beneficial, and that would allow organisms to improve and evolve. But the majority of the copying mistakes were detrimental, the cause of genetic disease. That's the theory, but today Watson is more concerned with the practical. The final place Watson wanted to take us on his tour of the future looked like just another lab.
In these two sections of the lab, it's mainly movement disorders and neurodegeneration. That's where a lot of patients in clinics above the age of 50 start developing tremors. So we have a clinical senior scientist.
This is Kay Davis, and this is her lab in Oxford, a place where they look for cures for a variety of different genetic diseases.
Design a treatment.
She has a team of scientists and all the latest equipment.
So all of this is genetic analysis. By that
It's an expensive operation, and it's supported by the fundraising of Jim Watson.
But it would also fund things like the PCR machines, which amplify the DNA several millions of times. So we can take a small sample and then analyze it, because we can copy it lots of times and then get enough of it to look at the details.
For Watson, labs like these are the culmination of a lifetime's work.
What we're talking about is what's real diseases, really serious diseases that we have an opportunity to do something about.
Serious diseases no child should be born with. There's no purpose to it. You know, it's all Darwinian. It's been, you know, selection of those the fit, and then constant generation of new variability. That's it. There's always new variability. If there had been no new variability, there'd be no evolution. But the price of this variability is some people are born with variability which is no good. You know, what I call genetic injustice. And what the world of human genetics is trying to do is to reduce the level of injustice. It's not out to create the perfect human or anything like that. It just sees this form of, just like any form of injustice, is corrupting if you accept it. So we can't accept it.
And that's ultimately why Watson wants to play God. But while he argues for forging ahead, even some of his allies have reservations about controlling our evolution.
The fact of the matter is, this is all uncharted territory, and we don't know what decisions people are going to make. And it's scary. It is frightening, and it's exciting, both.
If you have a child that is mentally retarded, it's easy to say, you know, why shouldn't I do everything I can to make sure that that child is now at least in the middle of the curve? Okay, that's a fairly simple kind of judgment to make. But I think, on the other hand, an important aspect of humans is that we're very different, and we actually all have different types of intelligences. And to try to push one type of intelligence versus another, I think it becomes possibly a dangerous thing.
I love the fact that we are as diverse a species as we are. I love the fact that we have such a diversity of temperaments and such a diversity of intellectual styles and ways of seeing the world and ways of going through the world. And I don't want to start narrowing that range. I don't want to give people a sense that they have to start narrowing and narrowing and narrowing and producing kind of little vanilla children. It's a kind of a ghastly thought.
I've lived all my life with people saying don't do something. So I'm used to these people. Most people are, you know, to one degree or another, are afraid of change. They don't know how they'll fit in with change. I think you often have to move in directions where if there was a majority of vote, they'd be against it because they don't really know what you're trying to do, and there isn't time to convince them. I've never worried about offending someone. I mean, yeah, I think it's just say the truth.
Jim Watson has always been controversial. It's probably in his DNA. But perhaps his most powerful defense of his science rests on the potential good it could do.
Scientists, doctors are the people who are going to do the miracles of the future. Let the lame walk, stop the cancers, restore sight. It's all sort of within our vision. And so I don't worry that, you know, some people say we're playing God, but that's an awfully good thing to do because people are looking for gods to do good things.
In our last interview with Watson, we asked him how he would like to be remembered.
Probably, you know, that I care for society. And you know, probably less selfish than I might have been.